Okay. Yeah, so I'm a hydrogeologist with the Maine DEP. I primarily was working on petroleum sites for a while, and recently moved into working mainly on PFAS sites. So this site was a good kind of intersection between those two areas. Next. So some general background about the petroleum program in Maine, and I know that several of my colleagues are on the call, so or on here, so this will be repetitive. So in the state of Maine, there's an average of 1.5 petroleum spills per day, and they range anywhere from vehicle spills, truck rollovers. We see a lot of home heating oil, AST spills, and then larger sites like a 6-oil release, historical 6-oil release. And so these sites are handled by the state, which is a little bit different than how other states handle them. Primarily, they are brought to the DEP through our response team, the hazmat team. They will do an initial review of a site. They'll go out and, kind of get a lay of the land and figure out what's going on, do the initial response action. And then if groundwater is at risk of being contaminated, then they bring in geologists or engineers. And if there's indoor air issues. So a lot of the cleanup is done in-house, and they're generally small sites. Next. So this site was brought to the DEP because there was a truck fire. This family's pickup truck apparently spontaneously caught on fire. It had a full tank of gas. And we're out in rural Maine. So 3 different volunteer fire departments responded to the fire, and they sprayed it down with foam. This happened in early February of 2019. And you can see in the 2 images on the right, it was February, there was a lot of snow, but all the white on the ground around that truck is foam. And in the bottom of the truck, inside the truck, that's all foam. And this was one of the new AB foams. So not full of PFAS or PFOA. This is supposed to be one of the new good ones. Next slide. So the site wasn't reported to the DEP until the end of March of 2019. And it was reported to us because the home on the site associated with the fire, they had the smell of gasoline coming out of their kitchen tap. And so they called us. We immediately went out to check it out. And so you can see in the map on the right, there were 3 different wells that were on the property. This is located up in Roxbury. If you're not familiar, Roxbury has 300 year-round residents. It's super, super rural. And this is a little compound area. So the hatched area in orange is the location of the fire. Just to the right of that is the trailer where the family lives. And then to the right of that is the home where the father of the homeowner lives. And then towards the river, there's a home where the grandfather lives. So all 3 of those homes have dug wells. They were all 15 to 20 feet deep, dug by the property owners themselves. So by the time we got there, it had been everything had been sitting there for 3 weeks. So we decided it wasn't worth doing an excavation because everything had pretty much gone into the ground by the time we got there. Next slide. Okay, so I've listened to the first set of presentations. There's a lot of people have explained a lot of kind of general information. So for this presentation, I'm going to kind of give 2 kind of pieces of background information. The PFAS task force recommended a 70 parts per trillion limit for a sum of 5, and those are circled on this chart here: the PFNA, the PFOA, PFOS, PFHPA and the PFHXS. We'll see what legislation does coming up, but that was the recommendation of the task force. We're also utilizing the EPA some of PFAS and PFOA 70 part per trillion health advisory. So on the other side of the slide to the left, I'm going to be displaying my data using stiff diagrams. I know these are usually used to show water quality, but they actually do a really great job of showing the fingerprints of for PFAS or PFAS compounds, PFAS. So the primary component in this new ABAFFF is the 6,2-fluorotelomere sulfonate. So it's an 8-carbon chain, and it's one of the polyfluorinated precursors. And that is always going to be displayed in the top left corner of the diagrams. And as you move around to the right, you basically go down a carbon. So you have on the top right, PFHPA, which is the 7-carbon chain. In the middle on the right, you have PFHXA, which is the 6-carbon chain. PFPEA on the bottom right, which is the 5-carbon chain, and then the PFBA, which is the 4-carbon chain on the bottom left. And I included PFOA on the left in the middle. It doesn't play a huge role in this site, but I put it there, kind of to show any data that we had for that. And as I go through these diagrams, you'll notice that the concentration will change on the x-axis. It's positive in both directions. But what I'm trying to show is kind of a general fingerprint versus actual concentration numbers. So what we're looking at is more the shape of that diagram versus actual numbers, like I said. Next. So in May of 2019, so remember the fire happened in February. We weren't alerted to the site until end of March. We were able to go out and do soil samples in May. Keep in mind the ground is super frozen. This is fairly far up north in Maine. And we got fairly low concentrations in soil. So if you look on the x-axis, these are both super low. The main component in the soil was that 6,2 FTS. Next slide. So we also use the top assay, and I think most of you should be familiar from listening to the first set of presentations, but the top assay is an oxidative pretreatment, and it can give you an estimate of the end products that may occur if you have these polyfluorinated compounds in a sample. So we told the labs if we were sending water samples in, if they see anything in it, to run the top assay on those samples. But if the samples were coming back clean, maybe we didn't need to run the top assay, which maybe we'll get into at the end of this. Next slide. Okay, so these are the results from the site well. Remember, these are dug wells, so they're really, really shallow. The area is next to the Swift River. It's pretty sandy. It's not designated a sand and gravel aquifer, but it's very sandy area. So in the graph all the way to the left, this is the water sample we took from the homeowner's well in April of 2019. So we went to the house and we ran the tap, and I kid you not, it looked like seltzer or Sprite coming out because it was just foamy and it smelled like gasoline. And it was one of the most alarming experiences I've had. And so you can see the primary component in that sample in April was that 6,2-fluorotelomere sulfonate. There's a huge peak there on the left. And the concentrations were 2,000 parts per trillion in their water from their well. As we move down the timeline, the May 2019 sample, we still primarily have that 6,2 FTS, that really big peak there. But you see that we're starting to get some of those shorter chain polyfluorinated compounds. So the PFHXA and the PFPEA are kind of popping out there. And as we move into August, we see a lot more of the shorter compounds. The ratio of that 6,2 FTS to the 5 and 6 chains, it's definitely shifting. And then in November, it's a completely different beast. We've got a whole bunch of that PFPEA in there, a lot of the PFHXA. And if you notice, the PFHPA, which is in that top right corner, is one of the PFAS 5 for the sum of 5 that the task force recommended. So while we were using this, the fire department used this new foam that's supposed to be better. One of the products of this oxidation is still that PFHPA, which is, I expect, going to be regulated at some point here soon. And then all the way to the right in red is the result of the top assay that we took in May of 2019. So it got rid of all of the 6,2 FTS. It converted all those precursors into the perfluorinated compounds. And you can see that it kind of expects you to get a lot of the PFPA with significant amounts of the PFHXA and the PFBA. So as we go through the timeline of those samples that we collected in April, May, August, and November, you can see that really beautiful shift to look almost exactly like the May sample, which is pretty, it's just beautiful, I think. Next. So one of the points I wanted to make, when you're looking at fingerprinting compounds like this, I think that showing them on the stiff diagram really, it's very effective. I copied those into pie charts in the bottom, across the bottom. So the results from May 2019 are the same results that are in that pie chart below it. And I just don't think it really shows the same, it doesn't give you the same story as these stiff diagrams do. I think the stiff diagrams do a really great job of kind of showing those changes. Next slide. So we were sampling at 9 River Street. That was the results that I showed before were from the site well, that 9 River Street well. And we were also able to sample the well, the other 2 wells on the property. The one on the right came back clean every time, which is great. What we would expect kind of in a really rural community like this. And the 14 River Street well did have some impacts. But the impacts were not above the PFAS 5. So it did have some of the PFHPA, but not in conjunction with the PFOA and PFAS and other compounds that would be alarming. But there definitely still was some down there. So we did see it. What ended up happening was they applied the foam to the fire area, and it traveled over the surface to that 9 River Street well and pretty much just dropped in right around the well. And then traveled towards that 14 River Street, got pulled towards the river there. Next. So at this house, we pretty much immediately put filters on their water supply so that they could drink it. And so the sample on the left was from November 2019. It was a sample we took before the filters. We put on 2 granular activated carbon 2 cubic foot filters. The engineer knows more about that than I do. But we did put those on.
5 minutes, Louise.
Okay. And so if you look at the x-axis in the graph on the left, that's the before filters raw water sample. You can see there's still really high concentrations of those shorter chain compounds. And the sample on the right was from between filters. So it was after 1 filter before the 2nd filter. And while it looks like there's a spike in that PFHPA, if you look at the x-axis, I mean, there's like almost nothing. We're going from 0 to 0.4 parts per trillion. So the filters did a really good job of taking that out, even those kind of shorter chain compounds. Next. Okay, so kind of my main points. The stiff diagrams do a really good job of showing the PFAS fingerprints. If you're looking at a specific set of compounds between sites or over time. I forgot to mention this before, but when we got our lab results back, those 6 compounds were the only PFAS compounds that were in the sample that we could see from the suite of analytes. So, so it was really easy to show those 6 compounds on that on those diagrams. The top assay is a good predictor of the degradation patterns. I know I've seen a lot of presentations that say they can't use it, like quantify anything with it, but for this site, at least it looks really good. And then the carbon filters work really well if you're working with AFFF. And then these small point sites are important too. I know there's a lot of talk about the naval bases and Ps and Loring and all these other big sites, but there's a lot we can learn from these small kind of one release sites that we can kind of watch over time. And next. And that's it. If you have any questions, I guess we're going to wait until the end, but you can definitely shoot me an email.